Residents were surveyed in order to determine which flowers to plant in the new public garden. A total of N participated in the survey, N people. Exactly 9 over 14 of those surveyed said that the color of the flower was important. Exactly 7 over 12 of those surveyed said that the smell of the flower was important. In total, 753 people said that both the color and the smell were important. How many possible values are there for N? Well, we need to create a little bit of a Venn diagram. And don't worry, it's not that bad. And I'll explain what I'm doing here. So first and foremost, let's talk about the fact that we have N as our total number of people participating. And I will call this A, B, and C, those sections. And this circle represents the color, the people who felt that the color was important. And this circle represents the people who felt the smell was important of the flower. So now we are told a few things. That A plus B, which is all the people in the color circle, represent 9 over 14 of N. And we are also told that B plus C, which are all the people in the smell category, the people who felt that smell of the flower was important, that is equal to 7 over 12 of N. All right? Now, one thing you'll notice is that these are all integers, right? A, B, and C represent the number of people, so they have to be integers. So the only way they can be integers if N is a multiple of 12 and a multiple of 14. So 12 and 14 is what N has to be a multiple of, both of those. So we have to find the least common multiple of 12 and 14. Well, 12 is going to be 2 times 2 times 3, and 14 is 2 times 7. So the least common multiple is 2 times 2 times 3 times 7, and that's 4 times 21, which is 84. So N is of the form 84K. It's got to be some multiple of 84. That's the only way we can make that an integer and that an integer, because A, B, and C are integers. Okay, so now that is established, let's plug in that value of N, 9 over 14 times 84K, and when you do, you get 54K for A plus B. And when you do the same thing over here, you get B plus C is equal to 7 over 12N, which is 84K, and that gives you 49K for B plus C. All right, so now that that is established, we now look at this part, which says that 753 people said that both color and smell were important. That number represents B. So B is 753. So that means A is 54K minus B, which is 753. And C is 49K minus B, which is 753. So now let's complete this Venn diagram with the values. Well, B they gave me in the question, 753. A I just figured out was 54K minus 753. And C was 49K minus 753. Okay, great. Now we have to figure out how many possible values are there for N. Okay, so that means I got to figure out a upper and lower boundary for my K. So we will first do the upper, and then we'll do the lower, and then we will combine them. So what is going to be the first limit? What is K greater than? What is what is K going to be greater than? That's going to give me sort of the lower limit. Well, we know that A is equal to 54k minus 753 and C is equal to 49k minus 753. And both of those obviously have to be integers, so both of them have to be positive. So that's what gives us our lower limit. 54k minus 753 has to be greater than 0. From this, you can get that k is greater than 13.9. And then the other one, 49k minus 753, that's also greater than 0. So that gives me that k is greater than 15.3. So combining these, k has got to be greater than 15.3. So k is greater than or equal to 16, because k has to be an integer also. It represents the value of n, and n is also an integer because n represents the number of people. So this is our lower limit right here. K has got to be at least 16. Upper limit. Well, upper limit is looking at the fact that a plus b, as we figured out, was going to be 54k, right? We did that right here. A plus b is 54k. And that represents what? The number of people who felt that color is important. So color is important. So the total is 84k. 54k said the color is important. So 54k said color is important, so 30k, which is 84 minus 54, must be the people for whom color is not important. Right? So that is the first part of this. So no tricks here. That's just simple sort of analysis of these numbers. Now let's turn our attention to this guy right here, which is the people in the smell category. They are basically the people of B and C, B plus C, I should say. And that is 49k. Now, these 49k people include some of these 30k, some or all of these 30k people. So let me write that out because that's an important point. These 49k people include some or all of the 30k people who said that color was not important. So that means that B basically would be equivalent to 49k minus 30k, and therefore that is 19k. And considering this statement, we can conclude that since B is 753, that 753 must be greater than or equal to 19k. And if you do the math here, k becomes less than or equal to approximately 39.6. So in terms of integers, that means that k has got to be less than or equal to 39. So combining, that means k is going to be greater than 16, but less than or equal to 39. Greater than or equal to 16 or less than or equal to 39. So every number from 16 to 39, and that gives me 39 minus 15, which is 24 possible values for k. And each value of k gives me one corresponding value of n. So that's 24 values for k, 24 values for n, and therefore number 25, the answer is D. Lara ate 1/4 of a pie and Ryan ate 3/10 of the same pie. The next day, Cassie ate 2/3 of the pie that was left. What fraction of the original pie was not eaten? Let's just give some numbers to make it easy. Let's say the pie originally was 100 units. So Lara ate 1/4, so she ate 25 units, and Ryan ate 3/10, so he ate 30. So that means what is remaining, if you subtract those, is 45 units. Okay? So then the next day, Cassie ate 2/3 of what was remaining. So she ate 2/3 of 45, which is 30. So what is remaining is 45 minus the 30 that Cassie ate, which is 15. So this is what's remaining from an original amount of 100. So 15 out of 100 is what was not eaten. Divide top and bottom by 5 and you get 3 over 20. So number 21, the answer is D. Each time Kim pours water from a jug into a glass, exactly 10% of the water remaining in the jug is used. What is the minimum number of times that she must pour water into a glass so that less than half of the water remains in the jug? Again, let's start off with a number. Let's say there's 100 units of water in the jug. The first time she pours, she will pour out 10 units. That means there's 90 left. Then 10% of 90 is 9, and that's the second time she pours. Then there's 81 left. The next time she will pour 8.1, and that is the third time she pours. And now there's approximately 72.9 left. 10% of that, which is approximately 7.29, that's the fourth time she pours. Now we have to take 72.9 and subtract 7.29, and that is about 65.6. And 10% of that is what she pours, 6.5, and that is the fifth time she pours. Then we have to subtract these, and again, you get about 59.0. She will pour 10% of that, which is 5.9. That's the sixth time she pours. 59 minus 5.9 is 53.1. And then now she's going to pour 10% of that, which is 5.3. And that's the seventh time she pours. After that, 53 minus 5.3 is 47.8. And at this point, less than half of the water is in the jug. And it took 7 times. 7 times she had to pour water into a glass for that to happen. So number 23, the answer is C. A box contains a total of 400 tickets that come in 5 colors: blue, green, red, yellow, and orange. The ratio of blue to green to red tickets is 1 to 2 to 4. So I'll call it X to 2X to 4X. The ratio of green to yellow to orange is 1 to 3 to 6. So the ratio of green to yellow to orange is 1 to 3 to 6. So I will write Z, 3Z, 6Z. What is the smallest number of tickets that must be drawn to ensure that at least 50 tickets of one color have been selected? All right. So the first thing we have to do is find out the distribution of these tickets, considering that they all add up to 400. Well, Z represents the number of green tickets, but so does 2X. So that means that 2X is equal to Z. If 2X is equal to Z, that means X is equal to Z over 2. So put that here. 4X would be equal to 2Z. So put that here. And then 3Z would be equal to 6X. So put that here. And 6Z will be equivalent of 12X. So put that here. So I can add all these guys up. And if I do, that will equal 400. So X plus 2X plus 4X plus 6X plus 12X is equal to 400. So what does that give me? 3, 7, 13, and 25. So 25X is equal to 400. So that means X is 16. So I'll plug those numbers back into here. So that means we've got 16 for blue, we've got 32 for green, 4X is 64, 6X is 96, and 12X is 192. So that's the number of tickets of each color. Now our task is the final sentence. What is the smallest number of tickets that must be drawn to ensure that at least 50 tickets of one color have been selected? Notice the spelling of the word color. Now you can tell it's a Canadian math contest. All right, so let's use extreme case scenarios here. We want to use the smallest number of tickets. Now, some of you might say, well, just choose 50 tickets. That's the smallest number, and it's the smallest of the answer choices. But here's the thing. If I choose 50, it doesn't ensure that I get 50 of the same color. Let's say I chose 50, but it was a few of them were green, and a few of them were red, and a few of them were yellow. That doesn't ensure. I have to guarantee. Now, how do I do that? And this is the way you do it. First, what you do is you select all of the blues. So that's 16 of them. So we've exhausted the blues. Now we select all of the green. That's 32. We're done. We've taken all the greens out. Right? Now, we can't choose them, meaning we can't look and see that we're choosing them. But what I'm saying is this is the extreme case scenario that just by chance, when you selected 16, all of them happened to be blue. Then you selected another 32, and all of them happened to be green. It's an extreme case scenario. Now what we do is we say, okay, I'm not guaranteed of having the same color. I'm going to select 49 now of the red. And just by some chance, they all happen to be red. Then I'm going to select another 49 tickets, and by chance, they're all going to be yellow. And then I'm going to select another 49, and by chance, they're all going to be orange. The reason I'm doing it like this is because I have to guarantee that when I choose a certain number of tickets, that there's going to be 50 of the same color. This scenario does not produce 50 of the same color. You see what I mean? So this scenario is possible. And we have to look at any extreme case scenario where it's possible to not have 50. This is a possible scenario where I chose 16 blue, I chose 32 green, 49 were red, 49 were yellow, and 49 were orange. So let's add these up, and when you do, you get 195. So far, in this extreme case scenario, we don't have 50 of any one color, but the very next ticket that's chosen will push me to 50. It won't be a blue or a green because those are exhausted. Those have already been all selected. But the very next ticket I choose must end up being either a red, yellow, or orange because there still are some of those left, right? Because 64, 96, and 192 are the total, and I only chose 49 of each of them. So the very next one, let's say if it's an R, a red ticket, boom, I've got 50 of them. If the very next one happened to be a yellow, I've got 50 of yellow. If the very next ticket happened to be an orange, I've got 50 oranges. Oh, 50 orange tickets. So 195 plus the very next ticket, and that would be 196. So it's a good little challenge in terms of counting. And therefore, number 25, the answer is D. Integers m and n are each greater than 100. If m plus n is equal to 300, then m colon n could be equal to the ratio m over n. I prefer to write it like that. All right, this is what this is what I call a time drainer. And on math contests, you have a limited amount of time, right? You only have an hour to get through 25 questions. It's not a lot of time at all. And this one is going to drain at least 6 minutes of your time, which is unfortunate. The only way I can think of doing this question is to go through each answer choice individually. And I'm not going to do that because you're going to get bored. So I'm just going to show you how it's done. Let's say I think the answer is 3 over 2. Therefore, I'm saying that 3 over 2 is m over n. Okay? So cross multiply and you get 3n is equal to 2m. Isolate for one variable, you get 3n over 2 is equal to m. Now plug it back into our main equation, m plus n is equal to 300. M we just wrote or figured out was 3n over 2, and you add that to n. And if you do, you get a common denominator, you'll get 2 over 2 like that. So it'll be 5n over 2 is equal to 300. 5n is therefore 600, and therefore n is equal to 600 divided by 5, which is 120. Substitute n back into here, and that will give you m is equal to 180. Now, are both of these greater than 100? Yes, they are. And both of these add up to 300. And therefore, the conditions are met, and the ratio is indeed 3/2. Now, I all of a sudden, decided to skip to choice E. Unfortunately, that was the last choice, right? So you probably, if you're doing this question in order, you'd go through A, do this, B, do this, C, do this, D, do this, and think, oh, geez, how much time has gone by? So it's just one of those time drainers, and the important take home with this is that you just got to be really fast. So number 21, the answer is E.